Hello, and welcome to Serverless 101. My name is Eric Johnson, and I'm a Principal Developer Advocate for Serverless at AWS. Serverless 101 is a video series to help you get acquainted with the AWS services that are serverless. In this video, I cover Amazon Simple Notification Service, also known as SNS. We'll talk about what it does and when you should use it. Let's get started. Amazon Simple Notification Service, SNS, is a fully managed messaging service for both application-to-application and application-to-person communication. If you're familiar with the concept of publication subscription, or PubSub, as a developer, Amazon SNS provides this capability on a much grander scale. SNS starts with a topic. A developer can create a topic to use as a point of communication for their application. Next, subscribers subscribe to the topic. These subscribers can be application-to-application with AWS Lambda, Amazon SQS, Amazon Kinesis Firehose, or third-party HTTP and HTTPS endpoints. These subscribers can also be application-to-person through email, SMS, or mobile push notifications. A single topic can have many different subscribers and types of subscribers. These subscribers can be internal or external, depending on the permissions set by the developer. With the topic in place and the subscribers subscribed, the application can now send a single message to the topic and have it relayed asynchronously to every listening subscriber. This PubSub architecture provides many powerful use cases in event-driven architectures. Let's talk about a few. First of all is the fan-out pattern. Let's say I have an event in my application that triggers multiple independent processes internally and externally to my application. For example, I receive a system alert from an IoT sensor on my factory floor. I need to 1. Stop the automated production line. 2. Notify on-site staff immediately. 3. Notify stakeholders. And 4. Save a record of the report. In this example, my IoT device sends a message through an API endpoint that invokes a Lambda function. The Lambda function evaluates the message and publishes a message to the alert SNS topic. This message then invokes a subscribed Lambda function that shuts down the operations, and another Lambda function records the incident in an Amazon DynamoDB table. SMS messages are immediately sent to any phone numbers subscribed to the topic, which alerts the on-site staff. Finally, my stakeholders' email addresses are also subscribed to the topic, and they will have an email waiting for them in the morning. Now, I could have done all this in a single Lambda function with a significant amount of code. However, through the power of SNS, I am able to do all these operations simultaneously. Additionally, I don't have to code for the different subscription types. SNS handles that out of the box. In fact, my application is not even aware of the subscriptions. It simply publishes to the topic and lets SNS do the heavy lifting. This brings me to my next use case: decoupling applications to increase application reliability and uptime. When building applications, it is easy to get caught in the trap of functions calling functions and building in unneeded dependencies in an application. This is no different when using serverless. An anti-pattern in serverless development is to invoke one Lambda function from another Lambda function. If the second Lambda function has an issue, then the first function can become inoperable as well. Instead, a better pattern is for the first Lambda function to publish a message on a topic, and the second Lambda function subscribes to that topic. This allows the first function to make the request and move on. If the second function has an issue, SNS will retry the invocation based on the retry configuration. This reduces the need for developers to handle retry code within the Lambda function and makes for a reliable application that degrades gracefully. I could list hundreds of other use cases for SNS, but hopefully you get the idea. SNS offers many features to help move events through your application. One feature is the ability to filter events. To explain this, let's go back to our factory floor example. Let's say the system detects some issue, but there's not a need to shut down operations. In this case, a warning is sent to the alert topic. This will still alert the on-site staff, and record the incident in the log. However, using filters, I do not invoke the Lambda function to shut down the operations, and the stakeholders will not have an email waiting for them. A second helpful feature is the first in, first out, or FIFO topic type. These topics ensure that the subscribers get events in the exact order they were generated. These types of topics can also integrate with FIFO SQS queues to maintain order throughout both. If you're not familiar with Amazon SQS, I cover that in another video in the Serverless 101 series. Finally, I want to talk about the throughput of Amazon SNS. A standard topic has a maximum per second throughput that is virtually unlimited. It provides best effort ordering. Occasionally, messages might be delivered in an order different from which they were published. FIFO topics will maintain strict ordering, but can still handle up to 300 messages per second. This has been a high-level overview of Amazon SNS. I encourage you to dig into the individual features of SNS to make it work well for you. For more information about Amazon SNS and other videos in the Serverless 101 series, follow this QR code. Again, my name is Eric Johnson, and you can connect with me at EDJGeek on Twitter. Thank you.